So firstly, I'd like to welcome those that have joined this session 2. Now this is of the IMS stream, and this is going to be about IMS virtualization with COPE, and we have John Butterwick, who I'll introduce as somebody that's been in doing IMS for well over 33 years, or indeed longer than that, but that's what it says on his CV. So he's an SMA, has been a systems programmer, he's been a DBA and an application programmer in his time, and obviously he's basically also done lots of product management for various companies. Now, what I'd like to do is just to say to everybody that during this presentation, he welcomes you to give him questions during it, verbally, preferably, and you can also ask questions at the end as well. So without further ado, I will hand you over to John.
Thank you, Dominic, and good afternoon to everyone. As Dominic said, my name is John Butterwick. I work for CompuWare, and what we're going to talk about today is IMS virtualization with COPE. And again, as Dominic had said, if you have questions, please bring them up when they occur to you, and we'll be glad to answer them. So here's the agenda. We're going to talk about what is IMS virtualization. How does a transaction run in COPE, which is IMS virtualization? How do we define the virtual environment? How does COPE transform programs and databases? And we'll talk about what does it mean to do transform programs and databases. Then what technologies work in a COPE system? How long does it take to set up a COPE environment? That'll be a big estimate. And then wrap it up with the benefits of COPE virtualization. So let's go ahead and get started with what is IMS virtualization for COPE. So again, what is IMS virtualization for COPE? It's the ability to execute multiple versions of IMS and DB2 programs in a single IMS subsystem. Okay, so what does that mean? So the pictorial, if you will, on the left shows a standard, or a non-COPE, I guess I should say, IMS system, where you have the IMS address spaces running in ZOS, which is where IMS runs. And you have various application programs, and they access various databases. That's a typical IMS environment. Over on the right shows a COPE environment, and most of it is basically the same. You have your IMS address spaces, you have your application programs accessing various IMS databases. But what's different in a COPE environment is within one IMS address space, you can have the equivalent of multiple IMSs. So in this pictorial here, it shows 4. So from an application programming standpoint and from an end user standpoint, it's actually no different. You log on to an IMS system as you always do, your emulator or however you're connecting to it. And then in a COPE system, you say, I want the subsequent transactions or other work I do from here on out, I want it to run in a particular virtual system. The application programs have no idea they're running in a COPE environment as opposed to a non-COPE environment. So again, the virtualization is within one IMS to make it look exactly like you had multiple IMSs in it. And in this pictorial, it shows 4 of them. And I'll expand upon that a little bit more to clarify a little bit more in the next few pages. So let's go ahead and keep going. Again, this is what's an IMS environment. You have different address spaces. You have an IMS control region address space always. You have always a DBRC address space, and you may have a DLI SAS address space. Now, COPE works in all the IMS environments. This presentation was put together based upon an IMS TM environment. But COPE also works in a DC control environment, which is an environment where you have IMS as a front end, but no IMS database. COPE also works in a DB control environment which is where you just have the IMS database component, and the front end is something else, typically CICS. So again, this presentation is based upon a DBTM environment, but COPE works just as well in any environment. So again, in this environment, you have the IMS address spaces, you have the supporting data sets for IMS up on the shown on the left, the logging data sets, the OLDs, the SLIDs, and so on. The DVD libraries, you have each of those comes within any IMS environment. You have the dependent regions, which could be batch jobs, totally independent of an IMS control region. You could run in message processing regions, fast path regions, BMPs, utility regions, and you have your application programs. For an IMS system, you can have one application program library or multiple. An IMS system can attach to DB2, or MQ can come to it as trigger monitors, or through other means. This is a typical IMS environment. So what happens if you need more than one, which is normal? You may have multiple test environments for different reasons, different levels of application programs, maybe different developers working on the same databases or programs at the same time, hopefully not the same programs. You may need one for quality assurance, different kind of tests, unit test, maybe system test. So there are many reasons why you would have more than one IMS environment. So in this next example, it shows where you have 4. And basically the same thing we have with 1 is replicated in this case 4 times. Now you can have some things common. You could have in the 4 systems, you could have your IMS databases shared, or they could be unique. You can have the application programming libraries shared, again, or they can be unique. Those are all choices that you have when you set up multiple IMS systems. Again, a lot of it would be replication. In this case, we have 4. So we would have 4 control regions running 4 DBRC address spaces and probably 4 DLI-SAS address spaces, multiple message regions for the different IMSs, and so on. So in a COPE environment, I mean, I could certainly have 4 IMSs, assuming that my system can accommodate the CSA and ECSA requirements. In a non-COPE environment, but maybe I want more than 4, and there are limitations to how many IMS systems can run in an LPAR. Basically, the ECSA will probably be the most constrained, or CSA. So what happens if I go to a COPE environment? Much of the duplication can be removed. If I take, for example, the 4 different IMS LPARs that are subsystems I showed in the previous screen, and put them into one COPE system, then a lot of the stuff is removed. We wouldn't have the 4 control region address spaces. We would have 1. We wouldn't have the 4 DBRC. We would have 1, and so on. So the logging data sets and the MFS and program lib, we would have one set of them. They will probably be bigger if you have more application programs than you would have had in any one. Then they would be merged together. The logging subsystem would just be one set of logging subsystems. It would still do the same amount of logging, assuming the same workload that you would have had in 4 separate IMSs was put into one. Your IMS databases, they could be unique to each IMS virtual system in the COPE environment, or they could be shared. Again, this same opportunities you have in non-COPE environments for sharing databases, sharing application programs, you have the same opportunities in a COPE environment. Program libraries could be separate, just as they would potentially be in unique environments. Again, the same with databases. So, all of the opportunities, all of the things that you can do in a non-COPE environment, you can do in a COPE environment. COPE supports all of the things that IMS supports. Let's talk a little bit more about how it does that. So again, within one IMS system, we show here, we have 4 virtual systems. And when a user logs on to a system, there's different ways you can say which virtual system I want this to go to. Typically, when a user logs on, there's a transaction that they can run. It's a transaction called COPE. And with that transaction, the user can say, I now want any work I do from here on until I change to go against this particular system. So again, you sign on to IMS like you would in a non-COPE environment. And then you can go into the COPE transaction and you can say, I now want to do all of my work on DB1A. If at some point in time you change your mind, and now you want to work on, for example, DB3A, you could bring that COPE transaction back up, and anything from then on will go in DB3A. There's all kinds of security opportunities available. You can allow a user to sign on to any system that they want, which is the scenario that I just described, or you can restrict a user to a specific logical system or sets of logical systems. And that can be controlled through your security product, RACF, or whatever you're using for security. If security products won't cover what you need, which is pretty unlikely, but potentially they won't meet your needs, then there's also COPE exits you could use to address whatever security needs that you have. Now we have some customers who have they've come and they say, well, I have multiple IMS systems right now, and I have multiple sessions. So maybe I'm monitoring the system, some kind of administrator, or maybe I just want to log on to different systems. So I might have 3 or 4 or 5 different terminal sessions going on to my different IMS systems. How do I do that in COPE? The scenario that I just presented, where your user logs on and for the duration it says I'm on this IMS system, or they have security put in place to say users can be restricted. There's another option in COPE where you can set it up to say whenever a user logs on, then they have to say which system they want to log into. In the previous scenario, once I've gone on, for example, and said I want to be in DB1A, I don't necessarily need to go back in and repeat that every time I get off of IMS and get back in. I'm always on that system until some overt action is taken to change the logical system that I'm on. So hopefully I made that, that clear. I didn't initially. But in this second scenario that I'm painting, where I want my user ID not to just be associated with one COPE virtual system or logical system, I can set it up so that whenever a user signs on, they'll have to say which logical system they want to be signed on to. And the combination of that L term and that user ID will say which logical COPE system they're on. So that way, the one user ID can be signed on to 1, 2, or 3, or n number of COPE logical systems at the same time. That's a choice that a user can make. Predominantly, what we've seen is where customers will have it where a user is assigned to one COPE logical system at a time, either through the COPE transaction, like I just mentioned, or through security, or even they can have a COPE administrator, which is the same as a DBA function, can assign users to certain systems where they can be as a default and maybe not allowed to change. So there's all kinds of security opportunities. And if you think about it, it works exactly the same way as if you had, in this case, 4 different systems. And 4 is not by any means a magic number. So there's no reason you can have, in this case, 16 systems. There's, you can have more than 4 or even more than 16. I worked with a customer not too long ago where we put on in one physical IMS system, we put in 17 virtual COPE systems. So again, the 4 is not the limit. There's an architectural limitation of 255, but no one at this point, no one's using that. They would use, everyone's using some subset less. I do know of one customer, they have multiple COPE systems, I think 3 or 4 in an LPAR, and they're running roughly 60 virtual systems. So that's in their case, they would need 60 IMS systems, and they use COPE to solve some of their problems, and that they couldn't have 60 IMS systems running in an LPAR. The CSA and ECSA constraints won't allow that. But yet with COPE, they're able to do that. All right, so, again, what is virtualization? It's really where you have one IMS subsystem, and within that one IMS subsystem, it behaves exactly the same way as it has multiple IMSs underneath that. And so how does a transaction run in COPE? So the next part, we'll talk a little bit about that and show how that works. So a minute ago, I talked about you sign on to IMS the same way as you would in a non-COPE system. You have some kind of a sign-on screen, enter your user ID and password. And then if you want to change the COPE system you're signed on to, and this is in the first scenario, you can bring up the COPE transaction, which is surprisingly called COPE. So just put in COPE and hit, space, hit enter. And this brings up the COPE menu. Now on this menu, there's multiple things you can do. It shows on the bottom here where it says under the avail, that shows the name of the COPE logical systems. Virtual systems and logical systems, the term is used interchangeably in COPE. So in this environment that we've set up here to show you, we have 5 systems available: DBT1, DBT2, 3, 4, and 5. And whenever you get into COPE, at the top, if you've already signed on to a system, it will show you which system you're currently signed on to. So when I signed on to this system to put this together, I was initially signed into the system called DBT1, and it shows my user ID. So to change systems, so any subsequent work that I will do, I simply enter the logical system that I want the work to go on this screen and press enter. It runs the COPE transaction and it would present this screen. Now what's very notable on this screen is that each one tells you that you've changed from one logical system to the next. And then it shows the programs, what library it's going to use to get your application programs. If you were in different IMS systems, your program library or your step lib, if you will, in the message regions could be different depending upon the system that you're running on. So the way COPE accommodates that is once you sign on to a system, there's a set of application program libraries associated with each system. They can be the same or they can be unique depending upon your requirements. But when you switch systems, it shows you the application program library that COPE is going to go to. In this case, when it's looking for the application program, the first data set it's going to go to is IMS.dbt2.programLib, and then a COPE load library, and then a common program library. And if it doesn't find the application program in one of those libraries, then it will search there's a DD statement in a message region for COPE called COPE step. It will search that concatenation for your user application program, and then it will search the step lib for your user application program. So again, the same thing if you were in different IMSs, your message regions could have different step libs within them. And this is one way that COPE simulates or does the same thing, where you can have your different application program libraries. So now in this case, I'm set up to run my application program in the DBT2 system. I could, in this case, press PF3, or I could clear my screen and bring up my application format. So for this example, I would have pressed F3 or PF3 on the previous screen and bring up my application format. And this uses the IMS IVP. Hopefully you're familiar with that. But I bring my format up, /4 IBTNO. Again, I could clear the screen and put that in. There's absolutely no requirement to enter the formats from the COPE menu screen. It's just an option there. So I bring up my format, put in 4 IBTNO. My application format comes up. I put in the information that the application requires and press enter, and then the application runs. And I had showed this information, this demo, to one of our marketing folks a while ago. And he looks at me and he says, "That's boring. What's this? It's no different than what I've seen before." And the answer is absolutely right. Boring. I might have liked to use a different choice of words, but it's exactly the same running in a COPE environment as you're running in a non-COPE environment. So I guess if we want to call it boring, that's good. But again, it's consistent with non-COPE environments. So that's how an application runs. A user gets assigned to a logical system, either by the COPE transaction they run themselves, and an administrator assigns them to it, or they were already, last time they ran, they were assigned to a certain system. From then on, it's exactly the same as in a non-COPE environment. All right, so again, the running of a transaction in the COPE environment is no different. The application program has no different. It doesn't do anything to accommodate the fact that it's running in COPE. So how do we set it up? How do we define this environment? So the COPE administration, there's an administration function with COPE, which is basically the same function as you would have with an IMS DBA. Once the COPE product is installed, and for installation of COPE, we work with the DBAs, the IMS system programmers, and whomever else is appropriate, security folks, to get COPE installed and set up and working the way that you want it to work. From then on, the administrative function is very similar to DBA function. What kind of things would you do? You would add maybe new DBDs, new PSBs, change the DBDs, change PSBs. The same things is in a non-COPE environment, the COPE administrator would do. Now, the COPE administration and setup is done through a set of ISPF panels. And this is the main the menu for the ISPF setup of COPE. And to show you how the setup is done, which would be initially, you would get into this panel and select option 1 for setup. And again, we would help you to do this when customers set this up. Off of this option 1 panel, there's another subset of panels. And this is where we would define the logical systems. And the one we saw previously, I had 5 logical systems defined. So we went in, it would be this panel here, press option 1 again, and it presents us with this screen, which is where we define the logical systems. On the COPE screen we showed previously, we saw where there were 5 systems, DBT1 through 5. This is the names where they came from. And now what's also a very key component of COPE is this previous system field. Notice that DBT1 doesn't have anything in the previous system field. So that makes DBT1 either a standalone system and within the IMS physical environment, or we call it a hub or a master, however you want to call it. The other systems, DBT2, 3, 4, and 5, they have DBT1 as the previous system. So what that means is that the DBT1 is their hub or their master. It's kind of like spokes to a wheel. When you have the arrangement set up like this, if I take an IMS resource, a DBD or a PSB, and I bring it into the DBT1 system, the hub, then that resource automatically becomes available to all of the systems that are siblings of that, DBT2, 3, 4, and 5, and so on. So when I would initially bring my systems into COPE, my resources into the COPE system, I bring them into DBT1, and that act of doing that, which we'll show you in a moment what that is, makes it available to the other systems, the sibling systems. If I now want it to be different, say perhaps I have a PSB and I want it to be different in DBT2, I want to add a segment or make some different change to it, then I would go and I would generate that PSB in a DBT2 system, and then that PSB would have the different attributes only in that system. So again, this allows the same as if you had, in this case, 5 different IMS systems. The resources don't always have to be the same. They may be the same or they may be different. And this type of setup allows it to be where you don't necessarily need to bring them into each system every time. You bring it into the hub and it becomes available to all we call them sibling systems. Some of our customers use this so that they don't have to bring everything in to the different systems. And bringing it into the different systems, the term we use is import, which I'll show a little bit later. We also have some customers who have multiple systems and they don't want this kind of environment. They want each system, when they want to bring their resources in, they want each system brought into all the resources and not put there by any defaults. So there's flexibility to address pretty much any way that you would want the setup to be.
John,
yes,
ask a quick question. It's Dom, the chair here. How does it interact with DBRC? Would you have to have a DBRC set up in all of the individual systems that you've defined in COPE?
So the question, let me restate it, make sure that I understand it, is about DBRC and can you set COPE up with DBRC and how would it interact with the individual logical systems.
Yeah.
And so the answer is the same as in a non-COPE environment. You can use DBRC to register your databases. It's optional, and you have the same opportunities in a non-COPE environment. You can have some databases registered with DBRC and some not, or force it all. So it really depends upon what you want. What happens is when you take a database and you bring it into COPE, so bringing it into COPE means import. So let's say I took a database and I imported it into DBT1, which is my hub system. What COPE would do is COPE would take your resource name, and let's say the resource name is called, I'll pick the IVP database, IVP DB1. When that is imported into COPE, what COPE will do is COPE would then take that database name, IVP DB1, and it would assign a unique name to that. We call it a COPE name or C number for that database in each logical system. So if I import IVP DB1 into the DBT1 hub in this environment here, it would create a unique COPE name, a C number for that database for DBT1, a different number for DBT2, 3, 4, and 5. Those are the names that COPE would use, and COPE would do the DBD gens with those names. And that's what the COPE would use from then on out. Now, to register them, what you would do is you would run your DBRC commands exactly the same way as you would in the non-COPE environment. You would probably run it in a batch job, executing the DBRC program. And the only difference in the JCL is you would put a statement that says, I want this set of commands to run in DBT1. And so you would do your initdb, your initdbds, whatever your different DBRC commands are, you would run those commands pointing to that logical system, and then COPE would take those commands and it would change them to be the init and then the COPE name for the database and issue those commands to DBRC, so they would be stored in the DBRC recon. So if you want all your databases to be registered, say in this case, in all 5 logical systems, I would do the same thing if you think about it, that you would if it was 5 different IMSs. You would run the DBRC probably batch job to init those databases in the 5 different recons. In the 5 different logical systems, just as if they were 5 different IMS systems. So did that answer your question?
Yes, that's perfect. Thank you very much.
Thank you. So again, in this environment, we set up the 5 systems. The setting up of the systems is normally a one-time thing. What we would do is when we work with customers, new customers to COPE, we understand their requirements. We create the number of virtual systems that they need now, and then we would also typically create more virtual systems so that should they choose to use them in the future, they're already there and ready to use. And that's something that we work with the customer to, again, understand their current requirements and potential future requirements. So once the systems are defined, now I'm going to go back to that process in the previous screen. I would have eventually submitted a job that would have defined those COPE systems. And the COPE definitions get stored in 2 places. One is a set of ISPF tables, and then 2 that also get stored in load modules. And the reason it's stored in load modules, when you run your transactions online, the online IMS doesn't deal with ISPF tables. That would be disastrous, even if you could make it work. And so to get that information online, to know what database name is associated, for example, with a particular logical system, that information is put into load modules, which are loaded during the COPE processing, when COPE processes in the message region. Now, earlier, I had showed you where when I switch systems, it gives a list of what application program libraries to go to for the different systems. And this is how you would define that. The COPE administrative dialog, then first one, option 1 for setup, and then option 5 here, specify message region data sets. So I'm going to show you how that works. So I'll come into this option 5 off of the setup panel. And in here we see the logical system names and in the data set names, the application program data sets that COPE is going to go to look for the application program, and the sequence number over on the right. Now, if you notice the step live concatenation for the logical system DBT1, is different than the if you will, step live concatenation for the system DBT2. And this is, when you run through this setup panel here, this is what defines that. So COPE will use this information to load your application programs. And this is ongoing. This is not, this may change as you evolve. You may certainly want to add application program libraries in here. And so at any point in time that you need to change the concatenation, what you would do is you would go to this panel and make the change. It would create a job that you would submit and run. And then that change could be effective one of two ways. You could cycle the message regions. It can be rather painful, probably prefer to avoid that. Or you could go into and issue a COPE transaction and tell it to refresh refresh this, and then it would be rebuild this. So it's very easy to go in and change, if you will, think of it as your step live for your application programs using this way in COPE. And again, this is not a one-time thing. You would probably do this multiple times through the life of the COPE systems, and that's what customers do. So really, that's how you define the virtual environment. It's the ISPF dialog that drives it. You go in, you define your logical systems. You go in and you would define if you will, the step lives for your application programs. And so fine, I've got them defined. How does COPE get set up? I haven't set anything up. I mentioned a minute ago, thanks to your question about DBRC, about databases, and COPE takes your user database name and gives it a COPE name, a C number. And we call that transform. So now the next thing I want to talk about is how does COPE do that? Well, what is that, and how does COPE do that? So it's driven from the ISPF dialog, administrative dialog that I showed you before, and we'll show you in a minute a little bit more. But how it works is that you feed into it initially, and potentially ongoing, you feed into it your stage one source. You would import, it's the import function into COPE using the ISPF dialog. COPE will take your stage one source and it will look at the resources in there. For databases, it will assign a COPE number, C number, for each logical system that you have defined in the COPE physical environment, because the database names under COPE will be unique. Now, even though COPE changes the names, you as a user you use the same name you always did. So if COPE takes your database IVPDB1 and names it, say, C12345, you don't, anytime you refer to that and doing your PSB gens, doing displays, anything you want to refer to it, you can use your username. You don't need to use the COPE name, and you don't want to use the COPE name. If I want to do my DBRC and init commands on it, or generate image copy commands, you can use the username. You just say which logical system, and COPE will translate that to the appropriate name for that system. So again, when you import the stage one, it will take all the databases in there and it will assign COPE names to them, C numbers. It will take your PSBs, and for your PSBs that are associated with the transaction, it will assign one COPE PSB name to it. It won't assign one overall. And the reason that there's not, in that situation, there's not a PSB name for each logical system is that doesn't work online. Your transaction names can't be changed. Your user transaction names are defined in your MFS. They're defined coming in off screens, all different places. You can't change the transaction name. And so in the IMS Sysgen, a transaction is always associated with a PSB. So it can be one PSB to multiple transactions, but a transaction is always assigned to a PSB. So in that case, that's the reason why for an online transaction, there's only going to be one PSB, and COPE can accommodate the PSB for that. What it will do is for the PSB, it will take the sets of PCBs and replicate them. For example, let's say that I have these 5 logical COPE systems, And so I import my PSB for my online transaction. It's going to have one PSB name that's going to be generated in the stage one, and that COPE's going to generate. But how do I differentiate that the logical system within the one PSB? I might want to run that PSB against, for example, my system DBT1 or the system DBT5. What happens is that COPE will take your sets of PCBs and replicate them for each logical system. So for example, if I had 2 database PCBs in my PSB, and now I import that into a COPE system that has 5 COPE logical systems, the PSB that COPE builds will have the 10 PCBs. It replicates that. And so that way, when the application gets control, COPE will say, okay, what logical system is this for? Because the DVDs will have different COPE names. And then it will allocate the databases for the COPE name and then pass the information on to your application program. Your application program will get exactly the same information as it would in COPE. It has no idea that the DVD names are COPE names. If you issue an inquiry against the names, you will get the same names as you would in a non-COPE environment. So one concern about that is, oh, what happens, how big are my PSBs going to get? If I have, maybe I have 20 COPE virtual systems and I have a PSB that has, say, 20 PCBs, how big is my PSB going to get? It could become so large that it can't schedule. So in order to accommodate that, COPE has a facility where you can say, I don't want my PSBs to have any more than N number of PCBs in there. So COPE will split those up in that case. So that's not an issue. Again, with the stage one gets imported, it will assign COPE numbers to the PSBs and the DVDs. And then that's what it will put in, build an IMS stage one with those COPE numbers in, and then you run your stage one through the COPE panels. It runs the same as it does in the non-COPE panels. Then you would take your DVDs, your DVD source or load, and you import that into COPE. And COPE will then take that and generate the correct COPE numbers for it. The PSBs, you can import those into COPE. You would import, again, either the source or the load. Some of this is, I work with some customers where it's a breather that they can do load because they may not have matching source. Sometimes the source gets out of sync. So using load can be a good option if you have any questions to your source. And it doesn't have to be an all or nothing. You might have different DVD libraries. In fact, many customers do have multiple PSB libraries. Some maybe you might want to import source, some maybe import load. Again, it's not one or the other. It's however you wish to do it. For dynamic allocation members, the same thing. You import either your source or your load. For MFS, and we don't typically import into COPE all MFS. We import only MFS that you want to change. You want to be different on different logical systems. So I know that many people would be very happy if they could read the load from MFS and build the source for it, but we can't do that. So we have to have the MFS source. So when you go through the COPE administrative dialogues, importing these resources, COPE will do the IMS gen just the same as it did if it was not COPE. For DVDs or PSBs, your databases, as I said before, they can be registered or not registered in the recon, your choice. If you're using the catalog, then for ACB gen, you can use it will invoke the catalog populate utility. COPE fully supports the IMS catalog and IMS managed catalog managed ACBs. And invokes the appropriate utilities for those if that's your setup. Again, the stage one, when you run your stage one, it the same as it would in a non-COPE environment. It puts it in the ResLive, the IMS STFS RESL. Again, same as non and COPE. To repeat again, the information about these cross-reference names, your username to the COPE names is stored in COPE ISPF tables for the processing in the ISPF dialogues, but it's also stored in load modules for processing online. And now I'll show you some of the screens that do that to set that up. Again, this is the COPE main development system screen, same screen as I showed you before. Now I'll show you option 2 as import and generate, where before I had showed you setup. So for the import screen, basically you say the input data set. In this case, I use the IMS IVP install logic. It would import the stage 1, what logical system you want to import it into. And then at the top, I would put the option 1 for source or S1, either one to import the stage 1. If I was doing DBDs, I would pick, either the number 3 or DBD, and then put the name of the DBD library, source or load there, and then put option DBD. It would generate a job that would then import those kind of resources, DBDs, PSBs, whichever kind of resources I want to generate. You could also use COPE, back to DBRC, if you have all your things you want imported and you want COPE to create the init data statements for the recons for each of the different logical systems, you could have COPE create that job for you here. So you don't necessarily wouldn't have to take all your DBRC definitions and rerun them. You could have COPE do this for you here. All right, so again, import is the act of bringing it into COPE, and then transformation is running utilities. Let me go back a screen. When you import DBDs and PSBs and MFS, at the time you import it, for DBDs, it will generate them as well. When you import MFS, it will generate it. And when you import PSBs, you can say, as part of importing, do I want to do the PSB and ACB gen? Those are the PSB and or ACB gen. I guess not and or. If you don't do the PSB, you can't do the ACB, but they can be generated there. I meant to mention that. So now back to the COPE, the menu, they call it transformation. For utilities that you haven't run, perhaps you didn't want to do the PSB gen before, or you want to do it again, you would go to option 4, and here's where you could again perform the transformation, which is the actual generation. This is where I would do my stage 1, so I would say mod blocks or control block, whatever kind of gen I want to do. My stage 2, I could do my ACB gens from here if I want to, or I could have done them earlier. So when you import, a lot of the resources are built at the time. There's other ways you can go in and make changes to them and generate them at that time. Or you could also come into this screen here and generate them off of this screen. The generation of them creates a batch job which you submit. It doesn't do it online. It's a batch job that you submit. So that's all for transformation. The COPE, we've done how did the transaction run in COPE? Boring, the same way as non-COPE. How do we define the virtual environment? We saw that with the ISPF dialog. How do we transform the databases? We saw that again with ISPF dialog. Now, what does COPE work with? Does it just everything has to be COPE? And the answer is no. COPE works with other products very well. It just uses IMS. So all of the products that IMS products become CompuWare, COPE supports. There's the list expediter, either Topaz RTSO, admin date IMS, file aid, CompuWare Exchange, the date program. And for a lot of other products, like there's a lot of tools. The BMC has lots of different kind of tools. IBM has lots of different kind of tools. There may be other vendors, I'm not sure. Those are the ones I'm most aware of. And now we're part of BMC. And for a lot of those, we have set up where we already support the tools. We front end the tool and we change the username to the COPE name, and it runs seamlessly. There may also be other tools that we haven't set that up for because it was never an issue, or new tools that may come about. So we've also created an API to allow vendors to call COPE and they get the username and transfer it to a COPE number, or vice versa. So we have an API for vendors, and for any tool that anyone interested in, we'll be glad to work with you and or whoever the vendor is. All right, so how long does it take to set up COPE? This is the magic number, and the answer is it depends. That's how do you answer that question? It really depends upon your environment and what's going on. But just to, people always want some information. So this is a really rough. And COPE is installed with SMP now. It's very easy install. I don't necessarily think it would take a day, but allow a day for the SMP install, get the product from the web, download the product install it. The importing of your resources, stage 1, DVDs, dynamic allocations, and so on, say a week. Again, that's pretty generous. A lot depends upon people availability. Define the IMS into stage 1 a day. That's pretty generous as well. It should be much less than a day. The biggest part really is loading your databases. What all databases do you want loaded? And it's a subset. If you have, 10,000 databases, I'm just picking a number. Do you have to have 10,000 all loaded in each system? No, you can have whichever subset you want. And again, that's the biggest part. And then set up CS connections. The customer that I referred to earlier, where we set up 17 COPE systems, we in the past, before COVID, we would travel and go on site and work with customers to set it up. And we were there for 2 weeks, and we got the 17 systems set up and running in the fashion that they wanted it to be running in. Now, certainly the world is different, so we would, in the environment we're now, we would support you remotely, which hopefully that will change, but we'll see. Again, that's just really, really general. Okay, now what are the benefits? Many of them I've addressed before, kind of trying to summarize them. I could create within one physical IMS, create multiple virtual environments. And why? Why do you want to do that? Why would you need that? Different phases of application development. Different versions of IMS applications and databases, and allow developers to work independently. Some it's, like they're in their own IMS potentially. And one of our customers, the situation that they found themselves in, they were a government agency, and they get rules from the government, and they have to be implemented by certain times. There's no grace period. You will implement these. And sometimes they would affect different rules, from different groups who support them, affecting the same databases and or programs. And so they had a bottleneck where sometimes one group would be working, the other group had to wait because they couldn't use the same resources. And then when that group would finish, now the second group could come in. So they were single threaded, which was causing big problems and lots of difficulty in reaching their schedules, accommodating their schedules. So with COPE solves all of that, because then they can have different versions of the databases and IMS applications at the same time. So again, it allows a lot more parallel application development and testing for a whole variety of reasons. Increase the number of IMS systems in a single LPAR. One of our customers, a current COPE customer, and they have, COPE is a product for test systems. It's not for production, not intended for production. And they have an environment where they were going to upgrade to one version of IMS, and they had some COPE systems and some non-COPE systems. And they felt that they couldn't upgrade IMS because of increases in CSA or ECSA. And so they couldn't upgrade IMS and keep the same number of IMSs in the LPAR. And so they said, we have COPE. Can we take some of these systems that aren't COPE and add them into our COPE system? And the answer was yes. And that's what we did. So and for them, it allowed them to upgrade their IMS. So that was a really big benefit of COPE. It saves them a whole lot of time and a whole lot of effort, a whole lot of money. Reduce the number of IMS system migrations. If you, for example, went from 4 IMS systems to 1, then you only have to maintain the 1. Lower resource by CPU by eliminating IMS address spaces. Yeah, that's you save some, but that's not really, an idle system it uses some resources, but probably not a whole lot. And really, really key is COPE is not a simulator. And it uses IMS. So as IMS continues to evolve, COPE can evolve because it just uses IMS. I think COPE's been around, I think it was developed in the 90s. And as IMS grows and changes, COPE is able to grow and change with it because it uses IMS. When IMS put out the IMS catalog, it changed the utility that gets used to generate ACBs and the way you populate that. So then it's a JCL. So the JCL that COPE uses, if you're using the IMS catalog, it invokes the new utility that IBM provides. So that's why COPE can continue to grow and adapt and thrive. So, before I go anymore, are there any more questions? First of all, thank you for your being here, for your attendance. And we appreciate it. And do you have any more questions?
So if you want to ask questions, then please remember to unmute and ask your question. I've got another question, and I think you've mentioned it already, but are you allowed to set up an environment that has, for example, multiple data sharing environments?
Okay, yes, you can. So COPE supports data sharing. So yes, you can do that.
Yeah, so could we have, say, you know, a data sharing environment with 2 IMSs and then another one with 2 and another one with 2, something like that? Yeah.
Yes. Yeah, there should be no problem.
Okay, thank you.
So thank you.
Any more questions for John?
And then I'll go ahead and then again wrap up. So, you know, we're always interested in your opinions. And so CompuWare is not part of BMC. So here's a survey. If you could, you know, go to that, it would be appreciated. But very important, please submit your feedback for the session. There's the code to scan and so again, thank you very much for your participation and attendance. I'm very grateful and thankful for the opportunity to discuss it with you. And I guess at that, Dominic, I guess pass it back to you, and thanks to you as well.
Yes, thanks all for attending this session today. And just as a plug, you know, there's the QR code, send in feedback. We always appreciate that, and it's quite important. We do love you giving feedback. We have got some more sessions lined up in the IMS stream. So this is the second one of 7 that there are. So there's one tomorrow. We have got other sessions. So just look on the agenda for each day, and it's sort of the light green ones are always the IMS ones. We'd like you to attend some of the others if you're interested. But thanks very much, John, for that. And thank everybody for your attendance today on this session. Thanks very much, guys.
Fine, take care.
Thank you.
Thanks very much.